So, okay. So we have seen till this part, okay. That is what happens regarding your medium and long transmission line. Okay. So we have seen up to that. And now I'll be telling another one point. Okay. So apart from this, during the calculation, you have to consider another one important thing, that is consider it to be a note. If the given values are in the form of impedance, the form of impedance, then impedance in the sense Zij. If they are giving the impedance value means, then you can find the admittance as Yij equal to 1 by Zij. So it is nothing but the reciprocal. So your admittance is reciprocal of your impedance. Okay. And hence, if they are giving Z equal to x plus jy means, okay, it is a complex term, complex. Okay, then yi of j will be equal to 1 by zij. So it will be equal to 1 by x plus j into y. So if it is in this form, it means you have to take your conjugate, x minus jy divided by x square plus y square. After taking conjugate, you will be getting this. I hope you know how to take conjugate. Okay. So now we will be going towards the algorithm, the uh, step-by-step method for solving your bus admittance matrix. Okay. So algorithm. First, you can start it. Second one. So get the power system network data. So this is the second step. Okay. So your third step is check the type of the data. Okay. Check the type of data. Okay. That is whether it is in admittance form. Okay, whether the given data is in admittance or it is in impedance form. Okay, so the fourth is if it is if it is impedance form, then then find the reciprocal. So you have to reciprocate it. Okay, so after that, then it is converted to admittance form. Okay, so this is your fourth step. So coming to your fifth step, so diagonal element. So to find the diagonal element, that is diagonal element in the sense self admittance. Self admittance. So here y will be equal to summation j equal to 1 to n yij. Okay. So if y shunt is given, then then yii will be equal to summation j equal to 1 to n yij plus y shunt divided by 2. Okay, and the sixth point is for off diagonal element or transfer admittance, your yij will be equal to minus of yij. Okay, finally form the y bus in matrix format. So eighth will be stop. So this is the algorithm with respect to the formation of your y bus. Okay, so it is simple steps you can easily follow. Okay, okay, so we'll be moving towards the problem. So first problem, for a given 4 bus sample power system, form a bus admittance matrix by direct inspection method. So the impedance value are marked on the diagram. Okay, so the diagram goes like this. So they have asked to find you the form the bus admittance matrix from the given diagram. So it is a 4 bus system. So this will be a first bus, this will be a second bus, this will be a third bus, this will be a fourth bus. Okay, apart from this, there's interconnection between your third and your first bus. Okay, so they have given 0.2, 0.4, 0.5. For 1 4 it is 0.3, and again it is 0.3. So this is the diagram they have given, and the values what they have given is that you have to see it is all the values are impedance value. So as per the algorithm, what you have to do initially, first get the data from the power system network. As per that, the data is given in the form of a single line diagram, and now you have to check whether it is the given data is admittance form or it is in the impedance form. So the given data is in the form of impedance. Okay, so if it is impedance means what you have to do, you have to uh, what you have to do, if it is in the impedance means check the algorithm and tell me.
Convert it into admittance, sir.
Yes, you have to convert them to admittance. So for that you will be taking the reciprocal of them. Okay, fine. So we'll be directly jumping into the solution. So this is the problem. Okay, I'll be drawing in a simple format the sideways, so it will be easy for you. Okay, so this is the given diagram, and from this first we'll be starting out with your y11. So this is your y11. Okay, so it is a very simple concept. Okay, that is how you can solve means you have to see what are the lines connected towards your first bus. So your first bus is connected by your y, First you can take it as y14. You can start from here. Otherwise, from here you can start. Y14 plus y13 plus y12. So you have to convert this. Have to consider only your admittance value, not the impedance value. So you have to take the reciprocal of it. So it will be 1 by y14 will be 1 divided by 0.3. That is this value. Okay. Otherwise, you can have like this: 1 divided by z14 plus 1 by z13 plus 1 by z12. So this will be equal to 1 divided by 0.3, this value, okay, plus 1 divided by 0.4 plus 1 divided by 0.5. So we'll be getting the values. So you just use the calculator and just tell it.
That's 7.833 Siemens.
Okay, fine. 7.833. Okay, if you want to just okay, you just put the unit also, but here they have just asked the matrix. Okay, and for y22 we will be moving. So for y22, what are the buses are connected towards your bus 2? It is only two lines. One is y23 and then y21. Okay.
Sir, in this Y11 we should consider on the right side Y11 also should come, no sir? The self
This
admittance one.
self admittance. Actually, in this problem, they didn't give the self admittance value. So if they didn't give, means it's no need to consider it. Okay. But generally, in most of the cases, they won't be giving that y11. Okay. So you just consider with the values what they have given alone. Okay.
So
So as
if
per
they are
the,
not given, we don't need to add it
yeah,
as well.
you no need to add it. Okay. If they are specifically giving, means you can consider it. They're specifically giving y11 value to be this with some values, means you can just consider over it. Otherwise, no need. Okay. But in this diagram, they didn't give. So it is best to leave it. Okay. And over here, first itself you just write total number of buses. It is totally 4. And what the I value takes is, the I value takes is 1 to n, that is 1 to 4. Okay. This also you just write it. So it takes 1 to 4. And now coming to the second bus, y22. Okay. So for the y22, it is connected with y21 plus y23. Okay. So it is equal to 1 by z21 plus 1 by z23. So it is equal to 1 by 0.2, right? 1 by 0. Sorry, z21 is 0.5. 1 by 0.5 plus 1 by 0.2. So you'll be getting the answer as
7 is
7.
7.
7. Okay. So this is what with respect to your y22. And next we'll be moving towards your y33. So I'll be moving. So y33 will be equal to, so again it is y, what are the things connected? y32 plus y31 plus y34. So it will be 1 by z32 plus 1 by z31 plus 1 by z34. So 1 by z32 is 0.2 Okay, that is 1 by 0.2 plus 1 by 0.4 plus 1 by 0.3. Okay, so what will be getting?
10.833, sir.
10.833. Fine. And finally, for a y44, it will be y41 plus y343. It will be equal to 1 by z41 plus 1 by z43. So it is equal to 1 by 0.3 plus 1 by 0.3. So you'll be getting the value to be
Plus 6.667.
okay 6.667. Okay, this is your y44. Okay, and next we'll be moving towards your transfer admittance or your off diagonal elements. So transfer admittance or your off diagonal. So since y bus is symmetrical, your yij value will be equal to yji. So it is enough to find yij alone, and you can just use the same value. And for this, your y12 we can start. That is the admittance corresponding to your first bus and your second bus, connecting your first bus and second bus, which is same as that of your y21. So which is that of minus y12. So it will be equal to minus 1 0.5. So it will be, so the value will be minus 1 of 0.5 will be equal to minus 2. Okay, and then coming to y13, this one, this line. So y13 will be equal to y31 will be equal to minus y13. So it will be equal to minus 1 0.4. So it will be equal to minus 2.5. Okay, so coming to y14, this is the same as that of y41. It is equal to minus y14, which is again equal to minus 1 by 0.3. So this value will be around minus 3.33. Okay, so after this y23, so for y23 will be same as that of y32. So minus of y23 will be equal to minus 1 by 0.2. So we'll be getting the value around v minus 5. Okay, so after this you have to only find your y24. Okay, y24 is not there. There's no connection between 2 and 4. So if you need, you can just write it and can put 0. Okay, so here your y24 be equal to y42, as it is present in your matrix. It will be equal to minus y24. So it will be equal to 0 because there's no connection between your second bus and your fourth bus. Okay, and we'll be going to y34, the same as that of y43 minus y34, which is nothing but 3 and 4, it is minus 0.3. Okay, so minus 0.3, so it will be equal to minus 3.33. So finally we got the value, and now you have to represent in your matrix format. So matrix form, here the matrix form is y bus is equal to, so initially you have to start with y11. So your y11 value is 7.83. First you write your diagonal elements, then it will be easy for you. After that y22 is 7, y33 is 10.88, and y44 is 6.67. And then start with your y12, it is minus 2, followed by minus 2.5, followed by minus 3.33. Then y21, it is the same as that of this, since it is symmetrical. So minus 2, minus 2.5, then minus 3.3. Okay, because it is symmetrical, and this value corresponds to 5, 0. So here comes 5 and then 0, and it is minus 3.3, and this is minus 3.33. So this is how you have to find your bus admittance matrix. So very important problem you can expect. After this, we'll be dealing with some complex numbers. Okay, so this is a very simple problem, and in the upcoming problem sessions, we'll be dealing with some complex numbers. Okay, so I'll be sharing this Jamboard also with you in the Google Classroom. You just see through that also. Okay, so I hope you are able to understand. Okay, so with this we can stop today's lecture with this problem.